Hi guys. Normally I do videos for my algebra students, but I haven't done any YouTube videos for my geometry students, so I thought I would start now here with this topic of proving triangles to be similar or proportional, since it typically is challenging for some people. First thing we're going to look at is, well, three things that we're going to look at is how to prove triangles to be proportional or similar, and the first one is angle-angle postulate, and then we're going to use two theorems, side-side-side and side-angle-side. Then we're going to use those theorems to solve for some unknown angles and side lengths. So the first thing I want to look at, and this is not in your note handout, but it actually is your yellow reference sheet. There seems to be some confusion here on congruent triangles, so I want to go back to that for a minute before we head into the similar triangles. So up here, remember, how did we prove congruent triangles? Side, 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 that meant three pairs of side lengths were congruent. Side, angle, side, that meant two surrounding side pairs were congruent, and the angle in between those pairs was congruent. Angle, side, angle, that meant that one pair of side, included side, was congruent, and then the angle pairs surrounding that included side were congruent. And then angle, angle, side. The one we didn't use too much of was hypotenuse leg. If you remember, what did not prove triangles congruent were two things. The first one was donkey, and I'm going to write that in a nice way, side, side, angle. That does not prove. And the second one was angle, angle, angle. And the easiest way to think about angle, angle, angle and why it doesn't work is looking at an equilateral triangle. If we look at these two, I can draw two equilateral triangles that clearly are not congruent, one smaller than the other. But yet we know with equilateral triangles, they're both equiangular, and all of those angles are 60 degrees. So here, in this case, we've got three pairs of angles. In fact, they're all congruent. They're all 60 degrees, but the triangles are not congruent. That's why here on similar triangles, we're going to look at angle, angle, angle. That is sufficient to prove that these two these two triangles are proportional or similar. The next one we're going to look at is side, side, side and side, angle, side. But instead of this side, side, side now meaning three pairs of congruent sides, what it is going to mean is three pairs of sides that are proportional or equal ratios. Likewise here we've got two sides, two surrounding sides whose ratios are proportional or equal, and the angle included is congruent. Let's take a look at angle, angle, angle. First of all, it's named angle, angle, but we know that that third angle is going to be congruent. So here, if A and F are marked as congruent and B and G are marked as congruent, then by third angle we know arithmetically they have to be congruent. So this postulate would show that triangle ABC is similar to FGH by angle, angle postulate. And the order matters. First of all, let me make sure that we know this is the statement of similarity. So if you're asked to write a statement of similarity, this is it. And again, just as in the congruent triangles, the order matters. So here, if A is marked in the first position, we need to write the corresponding vertex F, and likewise B and G and C and H. And we would say that these are congruent by angle, angle, or I tend to say angle, angle, angle. Okay, now let's look at the next example. Determine whether the triangles are similar. If so, write a statement of similarity. Well, first of all, we see parallel lines here, and whenever we see parallel lines, we've got to immediately start thinking about angles. So we know if those two lines are parallel, two segments I should say are parallel, that Q and N are congruent. Remember, the angles inside the Z pattern are going to be congruent if those two sides here are parallel. So angle Q, I'm going to write this down, is congruent to angle N, alternate interior angles. And likewise, P is congruent to M for the same reason. And we also have a third angle here. We could say by third angle's theorem or by vertical angles that those two angles are also congruent. So here, by angle, 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 by angle, 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 we could say triangle QXP. I could put those in any order I want, but now I have to write corresponding orders. So Q is corresponding to N, then I would write M and X. All right, let's take a look at another example. Determine whether the triangles are similar. If so, write a similarity statement. Well, we've got two angles here, 42 and 52 degrees. They sum to 94 degrees. And if I subtract 94 from 180, I would get 86 degrees. And over here on GFH, I've got 42 and 86, which sum to 128. And if I subtract that from 180, I would get 52. So by angle, 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 these two are similar. Now let's write a similarity statement. We've got A corresponding to G, A corresponding to G, and we don't have that in any of the other possibilities here. So by process of elimination, we can eliminate everything else other than B. All right, another parallel line example. We've got WZ parallel to XY, so we know we've got some alternate interior angles that are congruent. And we also have a third pair congruent, the vertical angles. So by angle, 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 these two triangles are congruent. Now let's see what similarity statement matches up here. W is corresponding to Y. So that's not going to work, that's not going to work. We know that they are similar, so by process of elimination, we're looking at A. All right, let's take a moment and look at two theorems that will also be sufficient enough to prove triangles are similar or proportional. First one is side, side, side. And as I had already mentioned, side, side, side in this case does not mean three sides that are congruent. It means three pairs of sides that are proportional. So you're looking at equivalent ratios. And they're color-coded for you here, although I know that they're not on your handout. So JK here is corresponding to MP. So you look at that ratio. Is that equal to KL in blue here to QP? And is that equal to the ratio of LJ to QM? And here, if they are all equivalent, then you can say by side, side, side that the two triangles are equivalent. And you do have to make note of corresponding order. All right, and then the next one is side, angle, side. So here we've got an included angle. The order matters. It's in between the two S's. So over here on the diagram, angle S is congruent to angle Y. Then all we need to do to be sufficient on proving similar triangles is to look at the surrounding side lengths. So is the ratio of the red sides here, SR to XY, is that equivalent or equal to the blue, ST to YZ? And if they are proportional and the included angle is congruent, then we can say that the two triangles are similar. All right, let's take a look at how do we use this side, side, side and side, angle, side. And this particular problem is a little bit tricky in that AB is not marked parallel to DE. So we really don't know anything about angle pairs being congruent. The only angle pair we know for sure is the vertical angles. In which case, if we're not able to determine what angles are congruent, which is what we use as our anchor to determine correspondence, then we have to experiment a little bit. So my first advice is, if you're in that position, look at maybe descending order or ascending order of sides. For example, on the left, AB is the longest side, followed by BC, followed by AC. And you can write down their lengths here if you want to. And then on the right side, the longest side is DE, followed by CE, followed by CD, 6, 5, 4. So let's try to look at first their ratios. So take longest to longest. AB is to DE, and you're asking yourself a question. Is that equivalent to BC to CE? Question. AC to CD. And go ahead and substitute in those numbers. 9 is to 6, question mark, as 7.5 is to 5, question mark, as 6 is to 4. And if you go through the numbers, you will see that they actually are all equivalent. They all can be reduced to 3/2. So in this case, it worked out. When we went with descending order on the side lengths, then we could see that all three pairs are proportional, so by side, 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 we can say triangle ABC is similar to triangle, and we have to put it in corresponding order. So the way we wrote these, the corresponding vertex to A is D. All right, so be careful of that. Now we could have just as easily taken just a portion of this proportion here. If we looked at the two surrounding sides around this included angle, we could have just as easily said that they were similar by side angle side, because we have a pair of surrounding sides that are proportional at the same ratio, and an included angle being, I'm going to write the angles out. Angle ACB is congruent to angle DCE. So we could have just as easily said side angle side. Now, if this proportion did not work, if you did not see proportionality here, you're still not done. We would have needed to look at AB to DE as AC is to CE, because those sides could have been the corresponding sides. So in that case, this type of problem is a little bit tricky. Moving on, let's determine whether the triangles below are similar, and if so, write a similarity statement. The triangles that we're looking at are these, maybe this top triangle here, this little one, MNP, and the bigger triangle that surrounds it, MRS. So let's take a look at first angles. Are there any angles that are congruent? And there certainly are. So angle M is congruent to itself, and it's in both triangles. So we have an angle that's congruent. We don't know anything about any other angles, but we do know something about sides. So let's look at the side MN. What's corresponding to MN? This side here, this whole side, MR. And we're going to want to look at that and the other surrounding sides here, MP, corresponding to MS. So we're trying to see, are they proportional? Are those ratios equal? So substitute 10 in for MN, and hopefully you can see that MR is the sum of these two segments. Okay, so MR equals MN plus NR. That's the segment addition postulate. So 10 plus 15 is 25. We're trying to see, is that equivalent to 12 over 30? And in fact, they are equivalent. They can both be reduced to 2/5. So that checks out. We've got two surrounding sides that are proportional. We have got an included angle, so we can make a conclusion that by side angle side, triangle MNP is similar to, M is corresponding to itself M, RS. All right, let's take a look at another example, and here again, we don't know if PQ is parallel to ST. They appear to be, but we have no idea, and without having been given any information, we have to experiment a little bit. So we don't know anything about the angles here, but we do know we have the vertical angles are definitely congruent. So let's first experiment and take a look at the surrounding sides PR, look at the ratio of PR to RT, is that proportional to QR to SR or RS? So substitute 4 to 6, is that proportional to 2 to 12? And they are not. 4 to 6 can be reduced to 2/3, and that is not equivalent to, what do we have over here, 1/6. So our first attempt would say they're not similar, but we're not done. Without having those anchors, we have to experiment, as I said. So now let's take a look at other surrounding sides here, PR to RS. So look at PR to RS, or RS. Is that equivalent to QR to TR? And substitute 4 to 12, is that equivalent to 2 to 6? And in fact it is. That is 1/3 is equivalent. By the way, we're asking a question up here. They are equivalent, 1/3 to 1/3. Sorry, my 1/3 is a little bit messy. Let me get my eraser out. And that does check out. So by side angle side, we can say that they are similar. We can eliminate A automatically because we don't have any information about a third side. So side, side, side is not going to work. We could have eliminated angle, angle, angle. So we were down to B or D. Are they similar? Our first attempt said they were not similar, but our second attempt said that they are similar by side angle side. All right, I just wanted to point out on this chart a couple of things, and that is the same properties that we've been looking at all along. First we started with algebra, then we looked at segments, then we looked at angles, then we looked at congruent triangles. Those same three properties, reflexive, symmetric, transitive property, all apply to similar triangles. For example, if you remember transitive, if A equals B, this is pure algebra now, and B equals C, then A must equal C. Well, above here on the transitive property of similarity, if we say that we have one triangle similar to a second, and that second is similar to a third, then the first must be similar to the third. That's all it's saying, and the same other properties apply as well. All right, let's take a look at something a little bit more algebraic here. We have two lines marked as parallel, RS and UT. So we know immediately something about angles. We're told a bunch of other algebraic or numerical expressions for side lengths here. RS equals 4, RQ equals x plus 3, QT equals 2x plus 10, UT equals 10. We're being asked to find RQ and QT. So let's take a look at this here. First, are they similar? If they're not, we can't do anything. So the vertical angles for sure we know are always congruent. And U is going to be congruent to S, alternate interior angles. Let's write that down. And angle R, by the way, this is a U, not a V. Ugh, I don't like it. I got to rewrite that. Okay. And angle R is congruent to angle T. Both reasons here, alternate interior. I'm going to abbreviate. Okay, so that tells us right away, angle, angle, angle. These two triangles are similar. Let's start with a similarity statement. If I write UQT over here, corresponding order would say U is corresponding to S. Q is corresponding to Q, and T is corresponding to R. By the way, I never marked these, so I'm going to go and do so now. Once we have this, just by position here of the letters, it really helps us set up the proportions. So we know that QT over here, the second two letters, is corresponding to QR. So let's write that. QT is corresponding to QR as, now why did I choose those? Well, I chose those because those are the ones we have knowledge of on the length. And likewise, I'm going to say UT, the first and the third, is corresponding to SR. Now you're just substituting. 2x plus 10 is 2x plus 3, as UT is 10 is to SR, which is 4. Cross multiply, and remember you need to multiply that 4, distribute that 4 by the whole enchilada over here. So we've got 8x plus 40 equals 10x plus 30. And in the interest of just saving room here, I'm just going to verbally say the inverse operations. Subtract 8x from both sides, you end up with 2x over here. Subtract 30 from both sides, you end up with 10, and x equals 5. And now we're just simply substituting. So RQ here equals x plus 3, so that would be 5 plus 3, so that equals 8 units. And QT equals 2x plus 10, that would be 10 plus 10, or 20. All right, let's take a look at another example. Again, we're told parallel lines. That's key here. Without that, we'd have no knowledge of angles. So we can certainly always say that the vertical angles equal each other, and angle B, remember, inside the Z pattern, inside that Z pattern, we've got angle B is going to be congruent to D, and by either third angles or alternate interior, angle A is going to be congruent to angle E. So we use that knowledge by angle, angle, angle to set up our statement of similarity. So I'm going to use the top one first, A, B, C. So what is, oh, I don't like my similarity symbol here. What is corresponding to angle A? We've got E. B, we've got D, and finally C and C. All right, now just by, we almost don't even need to look at the diagram anymore. We can just look at these letters here, and we can say that AC, that's the first and the third, AC is corresponding to the first and the third over here, EC. As one of the other side lengths we're looking for, AB, first and second, is corresponding to ED. Substitute. AC, 3x plus 8, is to EC, which is x plus 2, as AB is 38.5, is to 11. And we would cross multiply. All right, cross multiply here, and I get 33x plus 88 equals 38.5x plus 38.5 times 2 would be 77. All right, I'm running out of room. If I subtract 77 from both sides, I end up with 3x plus 11 over here equals 38.5x. And if I subtract 3x from both sides, I have 11. I'm moving over here. 11 equals, what do we have? 5.5x. Therefore, x equals 2 if I divide both sides by 5.5x. All right, we were asked to find AC, so we're just going to substitute in. AC equals 3x plus 8, so we can say 6 plus 8 is 14 units is AC. All right, now we have something that's called indirect measurement. We're actually going to be doing this outside when it gets a little bit nicer. We're going to be using shadows as well as mirrors, and we're going to be doing this using similar triangles like this problem is setting up, but we're also going to be applying trigonometry eventually to the same types of problems and comparing the data. All right, let's look at this skyscraper. Josh wanted to measure the height of the Sears Tower in Chicago. He used a 12-foot light pole, and that's this right here, and measured its shadow at 1 p.m., which was measured at 2 feet. Then he measured the length of the Sears Tower shadow, which was 240 feet. So what do we have here? We've got the tower here. And if we're creating shadows over here to the left, the sun has got to be up here. Okay. So make a sketch of the situation, and there's a big assumption that we have to make here in order to use indirect measurement, and that is that this light pole has to be parallel to the Sears tower. If we do not assume that, then we're not actually totally sure that these shadows are going to be proportional. All right, let's go take a look at what we can write as proportionality. We've got this angle here that is within both triangles. Do you see the triangles? We've got the little triangle here, and we've got the big triangle outside of it. So let's take a look at the side lengths. We've got 2 feet shadow, and the small triangle is to 242 feet on the tower shadow, as the height here of the light pole, 12 feet, is 2x. And we would simply cross multiply. 2x equals, I'm going to bother multiplying 12 times 242 because I would just have to simplify anyway. And I'm going to divide both sides by 2, so I'm going to say 12 divided by 2 is 6. So the height of this Sears tower is going to be 242 times 6. And if I did my calculation right, then we would say, indirectly anyway, that the height of the Sears tower would be 1,452 feet. Here's a very similar type of problem here. We have a lighthouse, and we're trying to indirectly understand its height. Jenny stops to look at the tallest lighthouse, located in Cape Hatteras, North Carolina, and she measures a shadow, her own shadow, to be 1 foot and 6 inches, and the length of the shadow of the entire lighthouse to be 53 feet and 6 inches. Jenny knows that her height is 5 feet 6 inches, and she's going to try to set up a proportionality to indirectly figure out the height of the lighthouse. Again, we know this angle here, it's called, by the way, this is called an angle of elevation. It's equal to itself, and it's in both of these triangles. The small one that she's making with her own height, and the large one that's made with the height of the lighthouse. So again, we have to assume that she is parallel to the height of the tower. Now, why is that? Because we're not sure if these segments and her height and the lighthouse are going to be proportional unless we assume that. I didn't explain that on the previous slide. I'm going to do so now. If they are parallel, then we know that this angle here is congruent to that angle there because of corresponding angles. By third angles theorem, this third one is also going to be congruent to that angle up here by the peak of the lighthouse, or you could also say corresponding angles because they're corresponding. So by angle, 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 we're saying that these two triangles are similar. All right, let's set up a proportion here. Now, what do we see before I set that proportion up? Notice we've got a mix of units here. We've got feet and inches. X is in feet, so I would recommend that everything be put into feet, rewritten into feet. So 53 feet and 6 inches is the same thing as 53.5 feet. 5 feet and 6 inches, again, 6 inches is half of a foot, so this would be 5.5 feet. And 1 foot and 6 inches, they made it very easy for us, by the way, is 1.5 feet. So set up your proportion. First look at Jenny's shadow. 1.5 feet of Jenny's shadow is corresponding to 53.5 feet of the lighthouse shadow, as Jenny's height, 5.5 feet, height is to the height of the lighthouse. Okay, so we can cross multiply. We end up with 1.5x equals, and if you work through that math, it comes out to be 294 1/4, I think. So if you divide both sides by 1.5, you end up with x equals 196.1667 feet. Now, I really don't like the look of that in the feet. I guess you could round up and say 196.2 feet, but I think we might as well put the feet in inches. So if we have 0.1667 feet, how can I convert that to inches? Well, multiply. We know feet is up on top, and we want inches on top. So we want to cancel the feet. 1 feet or 1 foot is the same thing as 12 inches. These two cancel, and this comes out to be about 2 inches. So if everything is proportional, then x would be approximately 196 feet and 2 inches. Okay, so that concludes this video. I've had to edit it several times because my dogs keep barking. One of them in particular, this guy here. I'll show you. Kane. This is Kane. He's barked. This is Kane. He's been barking the entire time, and I've had to redo this video several times because my husband is out shoveling, and Kane does not want anyone outside without him. Okay, thanks for listening. This is about as long as my videos get. I try to keep them below 10 minutes, but this particular set of notes were long, so I promise they won't be this long in the future. Take care. Thanks for watching.